All right, so P2 is still, we're continuing in that Calc Honors, or the Calc Review chapter, okay? And this is part 2, which is inequalities. Again, everything that we talked about today, just like last week, should be review, okay? Everything that we talk about in chapter P should be review. So this is brief, and like I said, we're gonna go through all of this stuff, and then if you took your test last week, you're gonna get an opportunity to work on this assignment between today and tomorrow in class. And if you did not, if you're a senior or you need to take the makeup, then we're gonna switch gears and we'll talk about the test, and then that's what you'll do tomorrow. So this is inequalities, okay? Obviously, something we've been doing for hopefully a while. When you're solving an inequality, we solve it just like an equation, except for 2 scenarios: when we divide or multiply both sides of the equation by a negative number. When you do that, it flips signs. So if it was less than, it becomes greater than, less than or equal to becomes greater than or equal to, and so on and so forth. You're going to solve these, and then you're also going to sketch the graph of the solution set. So these are on a number line, okay? You remember last year you did like open dot, close dot, but the pre-calc books change it to now be a bracket or a parentheses. Bracket means or equal to, parentheses means just greater than or less than without the or equal to. So if you had already solved and you ended up with a statement like x is greater than -3, you want to graph that solution set. You need to plot the number that comes before and after it at minimum. So I can do -4, -3, -2. You don't need to do too much more than that. And then you're going to use a parentheses because it's not or equal to, and greater than would point to the right. The second one says x is less than 2. So again, plot the same, the 3 points. So 1, 2, 3. This time it's less than 2, parentheses, points to the left. Then comes x is greater than or equal to 3. So I do 2, 3, 4. This time it gets a bracket because it's got the or equal to. Greater than points to the right. And the last one, x is less than or equal to 4. It would be 3, 4, 5, and a bracket and point to the left. Now, if it asks for the solution written in interval notation, this is -3 to positive infinity, -infinity to positive 2, bracket on the 3 pointing towards positive infinity, and -infinity to 4 with a bracket on the 4. So 3 parts to that solution. The first is your inequality statement, the second is the graph, and the third is the interval notation. All right, so this one says solve the inequality and then sketch the solution on the real number line. 9x minus 1 is less than 3/4 times 16x minus 2. So what's one way to start it? You can distribute the 3/4. So 9x minus 1 would be less than. 4 would go into 16. 4 times 3 times 4 would be 12x. And then 3/4 times 2. 2 would go into 4 twice, and I'd get -3/2. Then I can subtract the 9x. Add the 3/2, which would be the same thing as 1/2, well, 1.5 minus 1/2, minus 1, so 1/2, less than 3x, and then divide both sides by 3, which is the same thing as multiplying by a third. Now we tend to usually try to rewrite this so that the variable is on the left-hand side because that's how our brain reads it. So this would be x is greater than 1/6. You don't have to rewrite it that way, but it normally makes it easier to graph or to actually read that statement out loud. Greater than 1/6, I'd have to have the 0 before it, the 1 after. Greater than, parentheses, pointing towards the right. How else could we have started it? I could have multiplied my entire equation by 4, or inequality, not equation. Bless you. So I would have gotten 36x minus 4. The 4 would cancel. 3 times 16x minus 2. Remember when we multiply things on the outside, it doesn't also go to what's on the inside of the parentheses because it's going to change what's on the outside. When that gets distributed, it makes up for that change. 36x minus 4, distribute here. Subtract the 36x. Add 6. Divide by 12. Same answer. Okay. You choose. Completely up to you. Do you want to get rid of those or not? It's completely up to you. Just be careful. Everybody good? Yep. Questions? All right. Now we're dealing with compound inequalities. So compound inequalities are ones that have two inequality symbols. Okay. If the expression is on the inside and then the two inequalities are on the outside, this is read as an and statement. So the one that is here, I don't know why that's there, sorry, ignore that. The one that's there is negative 8 is less than or equal to negative 3x plus 5, which is less than 13. This is one and statement, okay? Whatever you do to the middle has to be done to both sides. So if I wanted to solve this equation, what's one way to do it? Or solve this inequality? Distribute the negative? So I could do negative 8 less than or equal to negative 3x minus 5, which is less than 13. Then? Good. Negative 3 less than or equal to negative 3x, which is less than 18. Last step? Divide by negative. Good. And when we divide by the negative, we got to remember? Flip our signs. God bless you. Or is that your straw?
That was the straw.
Never mind, I take back the bless you. All right, so again, this is read out of order because the smaller number should technically be on the left. This would be negative 6 is less than x, which is less than or equal to 1. When we draw this number line, so I get negative 6, positive 1. You can put the number in between like a 0, but it doesn't really matter as long as you've got the range set up. The negative 6 gets the parentheses. And the 1 gets the bracket, and we shade in between.
You flip the sign when you're multiplying or dividing?
Both. Yeah, when you multiply or divide. But not just like if you're multiplying on the inside, we didn't, right? It's when you multiply the whole statement.
Oh.
Yeah.
What do you mean shade in between? Just the line.
Yep. So you could have also divided this by the negative 1 up here. You could have divided it in the beginning. You would have had to change your signs at that point. So again, you'd still end up with the same answer. You could do it either way.
Miss Chris Weiser?
Yeah.
Fiona's in the waiting room. Can you let her in?
I can't. So I'll tell her, but I already sent my attendance. I'll send it to her though. Thank you.
This really sounds music.
I don't know. Maybe I'm hearing things.
No,
It did? Okay. All right, then you start to mix the absolute value with the inequalities. So the absolute value rules tend to forget, okay? If the absolute value, once it is isolated, so you have just the absolute value on a side by itself, there can be something inside with the variable, but nothing on the outside of the absolute value. Once it's isolated, then you want to look at your statement, and if the absolute value is less than a number, then it's an and statement, and if the absolute value is greater than a number, then it's an or statement. So for me, I think less than, the word than actually ends in the A-N, so it's A-N-D. And great or, I know I'd spell it wrong if I changed it to O-R, but hopefully that reminds you that that's an or statement, okay? So when you look at A, that's read as the absolute value of x minus 7 is less than 5. This is an and statement. So I'm going to add the negative 5 to the other side of the equal sign, or the other side of the absolute value. I have the inequality sign going in the same direction. That's already there. I lose the absolute value from the middle, and then I finish my statement. Then whatever I do to the inside, you have to do to both sides. So I would add 7 and add 7 and add 7. and I get 2 is less than x, which is less than 12. On a number line, the 2 obviously goes to the left, 12 to the right. These would both be parentheses, and it would be shaded in between.
How do you know which way to put this on?
Whatever this, so once it's isolated, so like if there was a 2 on the front of this, I'd want to get rid of the 2 first. But once you've got just the absolute value, like read it in your head. And that is absolute value of this is less than 5. When it's a less than, it's an and statement. So you keep it together. So same thing for B, right? Except that says less than negative 5. Is it possible for an absolute value to be less than negative 5? No. So this is a no solution. If you don't catch it, you'll go to solve this and you'll go to shade it and it won't work. But save yourself the trouble. If it's less than 0, no solution. Less than a negative number, no solution. Less than or equal to 0 will have one solution. You'll just set it equal to 0 and solve it. All right, C says absolute value of 2x minus 7 is greater than or equal to 5. So this becomes an or statement. The negative 5 goes on the left, sign in the same direction, 2x minus 7, or 2x minus 7 greater than or equal to 5. So when it's great or, we split it into an or statement. Both get the middle. So I would add the 7, 2 greater than or equal to 2x, divide by 2. 1 is greater than or equal to x, or x is less than or equal to 1. And then solve the 1 on the right, add the 7. 2x greater than or equal to 12, divide both sides by 2, x greater than or equal to 6. So here's my or statement. X is less than or equal to 1, or x is greater than or equal to 6. So less than or equal to 1 is a bracket on the 1 pointing towards the left. Greater than or equal to 6 is a bracket on the 6 pointing toward the right. Questions on any of those? So again, they're simple. You just got to remember it. You got to remember the rules about the less than and the greater than. And then I'll say too that if there was an inequality, which I think I put in there, no. If there's an inequality, so let's say it's a negative 2. Let's just say I have this, right? I should have made it a whole number, make it easy, but it's fine. That statement can't be determined if it's less than or greater than yet, because there's a number on the front. So the first thing we have to do is divide both sides by negative 2, and it changes the direction of our signs. Then I determine if it's less than or greater than. This would also be a no solution, but if that was positive, you would be able to make it less than, so it would be an and statement. So this would be no solution, but let's say it said this. If I had that statement, I would first divide by negative 2. Absolute value of x minus 1 would be less than or equal to 5 halves. And it's a less than, so it would be an and statement. Like that. So you can't determine if it's an and or an or until that absolute value is isolated. Still good? Questions? All right. Last one is quadratic inequalities. So when you're setting up a quadratic, so you've got an x squared, you have to solve it as though it's an equals, and then you test your points. So we did this when we did like domain probably about 3 months ago. we talked about this like briefly one day. Okay, so when I'm solving the inequality for A, let's say, I pretend like that is equals, okay, to get our test points. You could also factor this, so I can move the 16 to the left side. I can factor the difference of 2 squares, or I just solve it as though it's a square or x squared equals 16, and I get x equals plus and minus the square root of 16, so I get x equals plus and minus 4. Those are our test points. So I do -4 and +4. And then I plug in a point from the left, from the middle, and from the right to test our points. So if I plugged in, let's say, -5, I'm going to plug it in here. -5 squared less than or equal to 16. 25 is not less than or equal to 16. So I rule that section out.
Why didn't you just plug in -4?
So you want to figure out which of those rank, because it should be the -4 and the 4, because it's or equals. Those will always work. You got to figure out the other ones. So then I'll plug in one from the middle of these, like 0. 0 squared less than or equal to 16. 0 is less than or equal to 16, so that range works. It is usually every other section, so I assume the next one's not going to work, but we're going to test it out. 5 squared less than or equal to 16. 25 is not less than or equal to 16, so that part doesn't work either. And then it's or equal to from the beginning, so these get brackets, and I shade in between. And my inequality statement would be from -4 to +4 like that. Guys, I'm not sure if I'll do the 5 points on the last test, but if I do, this is your friendly reminder that several of you have now got black screens. And we're awake. Magic. Questions on that one? So for B, same thing. I'm going to change it first to an equal sign in the middle there. Square root both sides, putting a plus and minus in front of the one on the right. And then add the 3. And I get x equals +3 plus 1 and 3 minus 1. So 4 and 2. Set up your number line. 2, 4. Take a number left of 2. If 0's in the range, I always grab it. It's easier. Plug it in to the beginning. So 0 minus 3 squared greater than or equal to 1. -3 squared greater than or equal to 1. 9 is greater than or equal to 1. Again, it's usually every other, so we're assuming the next one doesn't work, but the one on the right will, but we're going to test it out anyways. 3 minus 3 squared greater than or equal to 1. 0 squared greater than or equal to 1. 0 is not greater than or equal to 1. And then plug in 1 from the right of 4. 5 minus 3 squared greater than or equal to 1. 2 squared. 4 is greater than or equal to 1. So there it works again. These get brackets, and I point my arrows out. In an inequality statement, this is x is less than or equal to 2, or x is greater than or equal to 4. So it points in both directions, which makes it an or statement. Good so far? Okay, then the last one is in quadratic form. So we can't just split this and set it equal to like +17 and -17 because it's not something squared on the left-hand side. There's actually 2 ways to do this question. Who could give me one? I mean, there might be more than 2 ways, but I can move this 16 to be on the side with the 9. so I subtract 16. And I get x squared minus 6x minus 7 is less than 0. And then you're factoring it. Factor it, x minus 7, x plus 1. Because the zeros on the other side, we can now split and solve this, and I get my test points are x is 7 and x is negative 1. So then I set up my number line, negative 1, 7, plug in a point left of negative 1, like negative 2. Negative 2 squared minus 6 times negative 2 plus 9 is less than 16. 4 plus 12 plus 9. That's 16. That's 25, which is not less than 16. So I rule out that part. Take 1 from the middle. 0 squared minus 6 times 0 plus 9 less than 16. 9 is less than 16. And then something bigger than 7. 8 squared minus 6 times 8 plus 9 less than 16. $25 is not less than 16. So my solution set is going to come from that middle range. This time it's not an or equal to, so it gets the parentheses. Can anybody tell me another way to have started it from here? Well, you'd have to move the 16 anyways, but then you could do the quadratic, yeah.
X minus 3 squared.
You can actually take and factor that, right? So this would be x minus 3 squared less than 16, and then we can do it using the even root property like we did up there, okay? So there's not only one way to do these. You could, if you find a different way, that's okay too. If your brain sees it differently, just make sure you remember the rules.
What if there's a third way?
Well, technically with the quadratic, there is a third way. I don't know. Then you get that choice too. Questions for me?
So the homework is in class tomorrow?
Yeah, you could do it now. You could do it tomorrow in class if you already took your test. Like if you're taking the makeup, obviously you're taking that.